Hello everyone, my name is Ege Aksoy. I'm a student at Bilkent University and I'm majoring in electronics engineering. Today I will be presenting you my EE-102 term project, which is called Macro Scale. And this is my project right here, as you can see. What my project does is very straightforward, and you probably also can tell by the name. It's a scale that calculates the macronutrients and calories of a food, depending on the weight and type of the food. You may ask, how is this done? And this is done with the help of a pressure sensor right here. So now let me briefly explain how my project works. First of all, I use a VGA display as my display, as you can see right here. There are 6 parts, and 5 of these parts have 2 decimal displays as numbers, and one of them has 1 decimal display. Let me show you right here that this is the total protein of a food, this is the total fat of a food, this is the total carbohydrate of a food, and this is the total calorie of a food. This is the food type. I will be talking about this in a second. And this is the weight that is on the pressure sensor, that is on the weight at that is on the scale at that moment. So in my project, I use a sensor, as I told. This sensor is basically a resistance. Depending on how much pressure is applied on it, on this surface right here, the resistance of this sensor goes down, and the more pressure there is applied, so the more weight there is on the sensor, the higher of a current passes through the resistance. This is how I can convert the weight of an object into digital data. I give a voltage of 1.3 volts, as you can see here, and depending on how much pressure is on this element, the current and voltage changes that enters the bus history board here. And these entrances are basically analog to digital converters. They convert to analog data of electricity into digital data, into 16-bit digital data to be precise. And there is also 2 LEDs here. This green LED symbolizes that the project is functioning properly, and this red LED symbolizes the overflow state of the project. Okay, so now let me start by demonstrating how the project works. As you can see, I have a lock here. I will place this lock on the pressure sensor right here, and this lock will act as a weight, act as food basically in this scenario. As you can see here, the green section of the display is changing. This is because the sensor that I've used is a cheap one, and thus there's a glitch. It's not functioning very precisely, but nonetheless, it measures the weight of the object that is placed on it, as you can see right here. And here I have 3 different buttons. This button right here is the reset button. This button right here is the macronutrition addition button, and this button right here is the food type change button. I'll show you how these buttons work. So as you can see, I have a weight placed on this sensor right now, and the green display is changing. When I press the macronutrition addition button, you can see that the other displays have changed as well. The food type, there are 5 different types of food in my project. Let me show you how you can change the food type. By pressing the food type change button, you can see that the food type is changing. Now it's 1, now it's 2, now it's 3, and now it's 4. When I press it again, it goes back to 0. It's because there are 5 different types of food, and the types of foods that I've used are so food 1, as you can see right here, food 1 is leek, food 2 is chicken breast, food 3 is apple, food 4 is water, and food 5 is olive. Can you show here please? There are the different types of calories, protein, fat, and carbohydrates data of the foods here. And basically with a simple multiplication, the fat, protein, carbohydrate, and calories are calculated. So how I did the display was, I have used 100 by 100 bitmap arrays. As you can see here, for example, this is for the figure 9, this is for the figure 8, this is for the figure 7. I've used 100 by 100 arrays in order to create these numbers essentially. And other than that, I have the reset button as I've said. For example, let me show you how the project works. So think of my finger as a foot. I'll apply pressure, and when I press the food macro addition button, you can see that the macros have changed. This is for the food leak. So when I press again, it will add again the same data depending on the weight that I apply. And when I press again, as you can see, the total calories has reset back to 02. This is because I've used the 2-bit display here. And when this happens, it's an error, it's an overflow. And in order to indicate this overflow, I have this red LED here that shows the overflow state of the, overflow state. Okay, so let me show you how different types of foods function. By the way, when there's overflow, you need to press the reset button, and the green LED turns back on because all the states are reset back to their original values. So let me change the food type, for example, now. This is chicken breast. I'll apply pressure, and as you can see, the weight is up. It's around 60. And I'll press the button. As you can see, now there were 57 calories in this food, and 13 grams of protein, and 0.1 grams of fat in this food. There is no carbohydrate in chicken breast, so as you can see, it's still at 0. And let me show you another food example. Let me show you water. Water is the third one. I just reset back, and I'll select food type 3. When I go here and press on the pressure sensor and press on addition, as you can see, nothing is changing. This is because water has 0 calories, 0 grams of protein, 0 grams of fat, and 0 grams of carbohydrates, so it doesn't change. Let me show you another example. For example, olive. I've reset again. There was no need, but I still did. As you can see, I'm applying pressure, and then I press it. So this was 65 calories. This time there was 0.1 grams of protein, 6 grams of fat. This is because olive is a nutrition that is rich in fat, and 0.3 grams of carbohydrates. So as you can see, they are changing. Let me go to overflow again, just to show you that overflow is working properly. Okay, and I also used 2 different sub-modules in this project. The first one is the analog to digital converter. This is a read-only module that was created by the analog to digital converter wizard application inside Vivado. So let me show you real quick. I didn't make any changes to this. This basically allows me to transform the voltage data into a 16-bit digital data. As you can see, this is the code. And then I also used another sub-module. This is the clock divider module. The basic clock inside the Basis 3 FPGA is a 100 megahertz frequency clock. And this was not a proper clock frequency for my display. In order to have my VGA display work properly, I had to use a clock divider which turned my clock's frequency into 50 megahertz. And to sum up, in conclusion, I've decided to create this project in order to inform people about correct nutrition and correct calorie track. This is important because a healthy individual needs to track their calories and macronutrients. And I think the project was a success because it's working properly. Thank you for listening to me, and I hope you have a great day.